Okay, so let's go. I actually really like Bernoulli, and Bernoulli's, well, it's basically the applied physics, the M2, right? M1 mathematics. I gotta have a pipe. I gotta have a pipe. We'll get to the house one where there's actually this pipe feeding a house of water on a hill. I actually use these three definitions, not this one. He's got one more, but I wanted to use this up here for what it is. Who cares if I'm fucking smoking? You get math? Great. Great! I love it. It's outstanding. Alright, so anyways. Inside here I actually have these three equations. Everything you'll see on this board in a condensed version, right? I want it much more condensed to just the congruency or the, what's the word for it here? The, conservation. Excuse me, not congruency. They are conserved to one another. That A1 is equal A1 V1 is equal to A2 V2 or P1 and P2. So that's what they share in common with this water problem and this air problem over the house, or trying to stack up the water through a pipe of on flat ground, but now I have to have a high riser go up a hill for the house, right? When you're out here doing the water pump and stuff like that, I don't need the whole schematic to the operation. I don't need the Jaguar saw program. I just need to know how to fix the pipe inside here for the congruency or the conservation that has to deal with this house. So hopefully, I haven't watched this one yet. I've seen it said Bernoulli, and I like Bernoulli, but I kind of been on his set for this mathematical integral for M1. It's actually M0. Oh, it's actually M1 comparatively to M0, which MN would be the next set because this is all zeros and ones. Where generally you would say this is M1 to M2 to MN. When you're dealing with that, you get a lot of this X, Y, and Zeta, which is positive and negative. One's a neutral, three-phase motor things, which come up a bunch. Okay, so hey, trading plants every day. George Scoville coming at you from the STEM lab. Let's see if I can pretty this up, put a little cosmetology on this map here, and do what you can do with it in the quantum physics lab. So hang with me. So there's been some cool ones. I just want to throw out some, general pro notes. And I mean general. We're not just talking about rock here. This is McDonald's. This is crew, man, and you want to be mayor, president, whatever. It's all the same stuff. Anyways.
It's going to take care of solving some of these first order differential equations that we can't otherwise solve. And
not many people can just jump in.
Cool idea. So before what we talk about are substitution techniques that change homogeneous or like the
or having learned
substitution.
Or whatever.
That's
Anyway,
a composition
running some good green,
nice
1836s.
This is the house. Wind shear comes in here like a current of the river, dark web. Like, once you figure out what that is, the dark web has a value for these are the employees, the systems, the vacuum pressure you'll feel in this house, so this wind over this house to rip off the roof. Now, obviously, they're not just set on there as a roof. It's now. It's going to change things on code for Hurricane Alley or Tornado Alley, 200 mile an hour, 2x4. It probably felt like it just kicked you in the chest, right? But you have to grind this table down every time here. We do that here because it's still within the approximations of it's not arcing, it's not making a noise on the saw, it's within the approximations of the congruency or conservation of A1 equals A2. This operation is a pallet set operation. This is how you teach the math because it's going to give me a way to give it a value in two places that are in the pipes. Now, when I say I actually graph this, what I'm actually graphing is a time window. Here it's mathematics about...
Welcome to iLecture Online. And today, continuing with physics, in terms of fluid dynamics,
I would be doing time sets of turns. Now, I'll get different sizes, but they'll range from 3-footers because there's no reason to burn anything smaller than that to 12-footers. And there's a range of that. If I did all the 12-footers, they would have a set. Are there differentials in those 12-footers for Corey, for burn time, for readiness, for the cutout as it comes to the system? Just because the rock's the same, it takes me the same to burn it, doesn't mean I'm going to get all 12-footers. Doesn't mean that it's autonomous to just take the rock
after the first set and throw it to the table.
It
Doesn't mean that to take that off and change the orientation of stacks with certain guys, like how they pull stuff off and do things. Some guys, I just want them 1-to-1, 2-to-2, a stack at a time, because the math will cripple you down here. And then you're going to get pressed, then you're going to stop thinking straight, start losing digits.
Pressure at any point inside the pipe plus rho GH of the fluid. Now, rho would be the density of the fluid. G is, of course, acceleration due to gravity, and height is the height above some reference point. Plus 1/2 rho V squared. Again, rho is the density of the fluid, and V is the velocity of the fluid through the pipe. Again, it doesn't have to be a pipe, but for simplicity, it starts there. And
you just don't know
said
because
that
you've never
those two terms
experienced it.
combined
But now you learn how to
are
swim.
consistently on that, so a frame.
So,
Then you learn how to
which
fly.
means that if one increases,
Catch you in the next
something
one.
else has to